Hello everyone, this is Dr. Ian. For today, we're going to be working on how to construct a frequency distribution table, histogram, and an ogive. Statistics is one of the type of mathematics that we learned wherein we are using actual data and process it to make it or to give us a visual on how those data set behaves. And that is what we're going to be working on our lesson today, specifically on how to construct a table and graphs that will help you see and visualize how your data set behaves. So frequency distribution table is what we're going to be working on today, and by definition, frequency distribution is a tabulation of the numbers of individuals in each category on the scale of measurement. And that's what we're going to be working on. So let's begin with our first case for today. And our case would be growing boys. So to be able to construct and understand statistics better, you also need to be able to understand the type of data and how you are collecting or what you are collecting in your data set. And in this case, we're going to be acting like researchers, and as researchers, we need data, and this is the data that we have collected from our research. Now, suppose, for example, the researchers are interested, which is basically us, in determining the age at which adolescent males show the greatest rate of physical growth. A random sample of 35 10-year-old boys is measured for height and then remeasured each year until they reach 18 years old. Now, the age of maximum yearly growth for each subject is as follows. So we have collected the age to which the individual or the boys in this particular data set had their maximum height on that age or growth spurt. And in this case, we have this data set, and from our data set, this individual at 13 years old, that's when his growth spurt happened. And this individual right here at 10 years old, that's when he hit his growth spurt. And this individual, quite a little late bloomer, because at 18 years old, that's when he hit his growth spurt. So we have collected it, and 35 of them are in our research. And the minimum age, of course, is at 10 years old up until 18, because that's when we monitored their height. So basically, we recorded their heights each year at age 10 all the way to 18. And that's the recorded data set that we have gathered from the 8-year research that we did. So just pretend that we are researchers right now. Now, here are our ungrouped data, and we're going to first work on our frequency distribution table, specifically on counting how frequent those boys' growth spurt happen in a certain age. And we know that we have collected it from 10 years old to 18 years old. So that's going to be our first column. This will be our age of maximum growth spurt, which is at 10, 11, all the way to 18. So the spread of our distribution is 8 years from 10 to 18. And what we're going to do is to systematically count the number of individuals or boys in this particular data set that had their growth spurt at 10 years old. And in this ungrouped data, be systematic when you are working with frequency distribution table, because this is a test of your patience and accuracy. And to be able to do that and to be able to be accurately counting, do it systematically. And in my case, I do it by column. So column 1, no, no. We have 1, no, 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 no. So this one, I have 1 right here. That's my first tally. And for 11 years old, go to the second column. No, no, no. 1, 2. So we have 2. And that's how you collect your data or count your frequency systematically. And of course, we're going to do it for 12, 13, 14, 15, 16, 17, and 18 years old. And now we have counted all the growth spurt at that particular age, and we are seeing their frequency on this column. So we are now basically constructing our frequency distribution table, and this is the first half of our FDT because now we're going to be working on our relative frequency. And what is relative frequency? It's basically just converting our frequency into its percentages by the total, which is 35 boys. So 1 out of 35 is 3%. So you're going to be using your calculator to compute for those percentages accurately and more efficiently. But if you wish to do it by hand, you may do your long division as you please. But for me, I use the calculator. So at 2 out of 35, my calculator says 6%. And you are seeing that I am also generating my histogram right here. Now, to give you a better look on how I constructed my histogram, so first, your horizontal axis, it will be the ages of boys in our data set, and the minimum is at 10 all the way to 18. So by scale of 1, so each unit is their age. And for my horizontal axis, I'll of course label it maximum yearly growth of the 35 boys. So this is my horizontal axis, and my vertical axis, it will be my frequency, and my frequency, I have a minimum of 1 and the maximum of 9. So I'm going to count from 1 all the way to 9 for my height or my vertical axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is my maximum and this is my minimum. And now I'm just going to draw a vertical line for each unit. And I do this because it's a lot easier for me to draw my guide when I'm working on my histogram. Forgive me for a crooked line because I'm not using a straight edge. So for you guys, make sure to use a straight edge or a graphing paper so that you will have a more accurate representation of your graphs. Not like mine, which is I'm just approximating, but I just want to show you how it's done so that you would understand how the computer is generating those bars from scratch. So at 10 years old, the maximum or the frequency is at 1. So this is 1. So this is my frequency for 10 years old. And from 11 years old, my frequency is at 2, 1, 2. At 12 years old, the frequency is at 5, 1, 2, 3, 4, 5. Somewhere here. And then I produce, or I will be able to produce all my graphs using this technique. So this is how you construct your histogram or your graphs from scratch, which you will be doing for most part on your own. So let's continue. So at 5, so we have 12 years old, we have 5 counts. So 5 counts is right here, and it's 14% as its relative frequency. Now you're seeing a more visual approach on how we see those percentages with the relative frequency, because the height of our bars is determining the percentages of those individuals in each of this category. So next category is at 13 years old. 7 out of 35 is 20%. So this is 20%. And then at 14, where most of the boys had their growth spurt, we have 26% for that. And as we continue, we'll be able to produce our histogram for the boys who had their growth spurt recorded in our data set. So this is now our data set, and this is what we call as the histogram, which is a representation or a graphical representation of our frequency according to its percentages. So now we're also seeing another type of density curve here, which is called the normal curve, because it's showing us the shape of our distribution, and that is one of the powers of creating a histogram. So now that we have our histogram from our frequency, we're now moving on to the second part of our FDT, which is the relative cumulative frequency and why we're constructing it and why we are graphing it. We're going to enter it on the next slide. So we're going to be working next with the cumulative frequency, and the cumulative frequency, to avoid confusion, is simply adding each of those frequency all the way to the last data set. So if our frequency is right here, which is at 1, 2, 5, 7, all the way to 18, and the cumulative frequency, you will start with the first item in your frequency, which is 1, and then you add it to the second row, which is 2. So 1 plus 2 is 3, and then 3 plus 5 is 8, and then 8 plus 7 until you finish or complete your cumulative frequency graph. So let's begin completing our FDT, starting with 1 at cumulative frequency and then add it to the next one, which is 2. 1 plus 2 is 3, 3 plus 5 is 8, 8 plus 7 is 15, 15 plus 9 is 24, 24 plus 6 is 30, 30 plus 3 is 33, 33 plus 1 is 34, and 34 plus 1 is 35. And now we have our cumulative frequency, which we are going to be using on the next graph. But first, instead of using the cumulative frequency for the graph, we're going to be using the relative cumulative frequency, or the percentages of those CFs out of 35. So what we're going to do is use our calculator again and find 1 divided by 35, which is 3%. 1 divided by 3, which is 9%. 8 divided by 35, which is 23%. And notice that the relative cumulative frequency will give you a different value than the relative frequency because we're using different sets of data set. Now that we're working on cumulative, notice that the percentages is going up and not fluctuating compared to the relative frequency graph that we have, or the histogram. So as we continue, 15 divided by 35 is 43%. 24 out of 35 is 69%. 30 out of 35, 33 out of 35, 34 out of 35, and 35 out of 35 is 100%. And now we're ready to do our relative cumulative frequency graph using our straight edge graphing paper, whatever you have. But first, how do we construct it? We start it with our horizontal axis, which is our ages. So we started at 10, 11, 12, 13, 14, and so on. And then make sure to label your graph. And this is basically the 35 boys growth spurt, which I'm not going to write anymore because it's in the screen that you are seeing right now. And then for the vertical axis, this axis will give you the percentages. So here, the relative cumulative frequency, we have the smallest at 3% all the way to 100%. So let's just do it in percent. So 10%, 20%, 30%, 40, 50, 60, 70, 80, 90, all the way to 100%. So we have 10% right here, 20% right here, 30, and so on. And again, I have a better representation of my scale on the screen that you are seeing right now. So forgive me if it's crooked. And now my guides is my vertical line. So I'll do my vertical line as my guides so that I can easily find the intersection of those horizontal and vertical axes. So when I graph my points, I'll be able to graph it with confidence. So first, at 10 years old, my relative cumulative frequency is at 3%, so somewhere here. 11 is 9%, somewhere here. 12 years old is 23%, 20%, so somewhere here. 13 is at 43%, 30, 40, 50, 43%, slightly lower, of course, so somewhere there, until you complete your dots. So let's do it here in our screen so that it's a lot easier to visualize and it's not crooked. So here is the 3% at 10 years old, 11 is 9%, 12 is 23%, until we complete the dots and give us the ogive. So this is now the ogive. And what does the ogive do? This approximate the percentile or the ranking of each individual compared to the whole entire group. So let's say we're going to use our percentile. Actually, if you use the RCF, this will also already give us the percentile of each age or category right here, which is at 10, 11, 12 years old. So here, if we want to find the percentile of the 10 years old, we have 3% or 3 percentile. So that means 3% of the boys had their growth spurt at 10 years old and below. And let's say you are at 17 years old. So at 17 years old, your percentile is at 97 percentile, which means 97% of the boys had their growth spurt at age 17 and below. So that is what percentile means. So let's say our approximated value of percentile that we are looking for is at 14 and a half years old. So at 14 and a half years old, we're going to approximate the percentile of that individual. And here, we just need to find its intersection on the ogive. And this is the intersection on the ogive. And it's giving us about 80%, close to 80%. So let's say 78%. But since we are just approximating and we're just using our ogive as a tool to approximate percentile, we can say that about 80% of boys had their growth spurt at age 14 and a half. So that is basically what an ogive means. And you can also look at it as the complement. So if you are going to see it on a different perspective, you can say that about 20% of the boys had their growth spurt at over 14 years old or 15 years old and over, or 14 and a half years old and over. So that is how you work out your ogive and the purpose on why we created the ogive and the relative cumulative frequency. And to give you more idea on what percentile is, so this is the growth spurt of the 35 boys that we had in our experiment or in our research. Now, let's use a different type of data, something that is easy to collect without waiting for 8 years. Let's just use an existing data, and this is the data that we have, the ages of the US president during their inauguration. So in our data set, George Washington, which is the first US president, he's at 57 years old when he became the POTUS. So at inauguration, he was 57. And Kennedy is 43 years old. Oh, really young president compared to Washington. So 43 years old when he became president, and so on. So this is basically what the data is showing us. And we're going to use this to answer this question. Was Bill Clinton a young president? And how are we going to answer this question using an ogive? Let's pull out the ogive. We're not going to do it from scratch. We're just going to find or use the ogive right here, which is the relative cumulative frequency graph of the US president's age during their inauguration. And we need to first know how old was Bill Clinton during his inauguration. And using our data set, we know that he's at 46. So he's 46 years old during inauguration, which is quite young. But how young relative to all the US presidents in this data set? So let's have our ogive back and find its percentile. So at 46 years old, which is his age, 46 is somewhere here. Its intersection is somewhere around 10%. So that is his percentile. So that means if we're going to interpret his ranking according to age in his inauguration, Bill Clinton is at 10 percentile, which means 10% of the US presidents are younger or the same age as Bill Clinton during the inauguration. Or we can also look at it on a different perspective. We can say that according to our ogive, it shows that Clinton's age places him at about 10th percentile mark. Therefore, Clinton was younger than about 90% of all the US presidents based on his age or based on his inauguration age. So this is how we use ogive and our FDT to interpret and answer some questions based on our data set. So your Numberbender challenge of the day, of course, you're going to be using this Ogive, which is from the US President's FDTs, and you're going to tell me if Abraham Lincoln was a young president relative to all the US presidents in our dataset. So what you need to do is to go back, use the Ogive, and approximate Abraham Lincoln's percentile so you can answer our Numberbender challenge of the day. And this is our lesson on how we use our statistics skill in creating our FDTs, generating our graphs like histogram and Ogive, and the most important part is to interpret and know how to use them to make sense of all those numbers and graphs in sentence or in verbal form. This is Dr. E, and see you again next time. Bye!